Okay, so we're ready for chapter 4, atoms. So now we're going to finally get into something that feels more like chemistry. It's not measurements and it's not matter, it's not energy. We'll be talking about the atoms. You're going to need to know the elements 1 through 38, number 47, 50, 53, 54, 78 through 83, and 92. 92 is uranium. I tried to go through and pick out just the ones that you need rather than say, memorize the table. You're going to need to know these in order to speak your new chemistry language. The best way to learn them is to use index cards to write the name on one side and write the symbol on the other. Don't worry about memorizing any of the numbers. You'll always have a periodic table, but you will not always have the name written out. So you're going to need to know these symbols. Okay, so what is an element? Elements are pure substances from which all other things are built. Make sure that shows. Okay, elements have only one type of atom. Elements cannot be broken down into simpler substances. You can break them into parts, but it's only subatomic parts, protons, neutrons, electrons. And most importantly, elements are listed on the periodic table. So if you need to know whether something is an element or not, you can always look on the periodic table. If it's not on your periodic table, it's not an element. We used to have a lot of trouble with people thinking that water is an element because I think it's one of Aristotle's elements. And water is not an element, so it does not appear on the periodic table. So we're going to be talking a lot about the periodic table. And here it is. The vertical columns, the up and down part, those are groups. We call those groups, and they contain elements with similar characteristics. Okay. The across are the horizontal rows, the going across, we call those periods. So we have periods and groups. The periods are numbered 1, 2, 3, 4, 5, 6, and 7. The groups, some of them have names. So we have the alkali metals, which is the first column. It's got hydrogen, lithium, sodium, potassium, rubidium, cesium, francium in it. It's this column right here. Right next to that, we have the alkaline earth metals. And we'll do those in green. This will be beryllium, magnesium, calcium, strontium, barium. So those are the alkali earth metals. We skip all the way over then to the halogens. The halogens are very, very reactive, and they consist of fluorine, chlorine, bromine, iodine. That's this column right there. And lastly, we have the noble gases. Now we'll move the halogens over. Noble gases. And they are the last column on the periodic table. Now the noble gases are very unreactive. They were called noble gases because they didn't deign to combine with the lesser elements. And so they're very unreactive. The halogens are extremely reactive. The alkaline metals are very reactive, and the alkaline earth metals are reasonably reactive. The other divisions of the periodic table we need to know are the metals and the nonmetals. Let me get the papers moved. So here are the metals and the nonmetals. First thing you'll notice, the metals are in red, and that there are many, many more metals than nonmetals. So the metals are in red, the nonmetals are in blue, and the semimetals or metalloids are in green. So if we look at this table, we'll be able to determine whether something's a metal or a nonmetal. We start with sulfur. Sulfur symbol is an S, and it's right here. It's in the blue, and so it's a nonmetal. Sodium, its symbol is in A, and it's in the red, so it's a metal. Mercury is Hg, and it's a metal. Uranium is 92, down here the U, and it's also a metal. Neon is here, and it's a nonmetal. Oops, non. And molybdenum is right under chromium. It's right here. And that makes it a metal. Okay? So we've got this chart to fill out. You're going to want to keep a periodic table handy. And I'm not going to be able to get all this done. It's okay. We'll just edit the end of this off.